Hi guys! So, welcome ulit sa YouTube channel natin. Now today, meron tayong bagong topic. We have the loads and structures. Specifically, we have the transmission of loads. Ito yung one of the first topics na i-discuss sa theory of structures na klase. And then, I think kasama dito yung determinacy and stability of beams. So anyway, next meeting na lang yun. So focus muna tayo dito sa transmission of loads. Now, siguro alam niyo na kung ano yung beams, yung mga frames, trusses, kasi nga na-meet nyo na yan during sa statics and strength of materials ninyo. So sa statics, you discussed kung paano kunin yung mga reactions tsaka bar forces sa beams and trusses. And then yun nga sa strength of materials, kinuha nyo din yung shear and moment diagram sa beams. So meron pa tayong iba pang mga structural members gaya ng columns, foundation na mamimit ninyo sa future subjects ninyo like sa reinforced concrete design. And then those structural members, guys, actually they will paano ba to ha? Yung mga buildings natin, yung mga bridges, these are actually composed of different structural members pinagsama-sama lang to resist the loads. For example, sa bridges, meron tayong mga loads from yung mga sasakyan. Okay? So, di ba, sa buildings, meron tayong loads dahil nga sa mga tao, and then meron tayong mga dead loads, ganon. So, these structural members will actually compose the structural systems that will resist these loads. So, and then those loads are transmitted, from the slab to the beam to the column and then foundation and then sa soil na. Okay? So dito guys, meron akong nakita na yan. Yeah. So this is actually a figure, no? So we have I think this is a good example para sa isang framing system, okay? Or sa typical structural system. So meron tayong slab, meron tayong girder, yan, beam, foundation. And then, I think since merong braces dito, kung mapapansin nyo, may braces dyan. So, siguro, this is assumed to be pin connected. So, hindi ito nagre-resist ng moment. Kaya, meron tayong braces to resist the horizontal loads. Anyway, baka nahihirapan pa kayo. So, ang i-discuss ko lang dito is paano matatransmit yung loads. And then, ano pa yung loads na kinakari ng mga members na to. Okay? So, anyway, guys, by the way, yung loads na niresist natin, guys, mga gravity loads lang muna, mga vertical loads lang muna. Okay, downward loads. So, dito yan, ang unang loads, ang sasalo talaga ng loads ninyo is yung slabs. Okay, yan. So, baka isipin nyo, sir, bakit naputol? Kinat lang yan para visible yung iba pang beams. Now, by the way, kung mapapansin nyo, guys, meron tayong mga letters, sa edges. Okay, para yan, mapangalanan natin yung mga members natin. For example, this is actually column FB or BF, yan. Beam, KL, and then girder. Now, by the way, sir, ano ba yung kaiba ng girder at saka sa beam? Now, for this figure, kung mapapansin nyo, mas mataas yung girder, compared sa beam. Okay? So, bale, ganito yung nangyayari. Yung slab natin, yung rectangular na yan, yung slab na yan, that is actually carried by the beams. Ito yung beams na nagkakarry ng slab yan. Yung beam KL, IJ, GH, at saka EF. Okay? Again, the slab is carried by the beam. Okay? KL, IJ, GH, and EF. Okay? Dito, papakita natin yan. Oh, later na. Sorry. So, and then, our beams, yung beams na yan is carried by another beam, mas malaki nga lang, itong girder. Girder, L, LF, okay? And then we have girder, KE. Okay? So, again, ang girder, guys, is just a beam pa din, but mas malaki nga lang yung beam. And then, yun nga, kinakari na yung mga maliliit na beams. And then, itong girder na to, guys, okay, itong girder na to is carried by the columns. Yan, yung FB, EA, TC, and LD. Okay, and then these columns are carried by the foundation. And then yung foundation, okay, kinakari na ng soil natin. So, bali, ganun talaga yung transmission ng loads from the slab to the beams, to the girder, and then column, and then foundation, and then, yun nga, sa soil na. Okay? So, check out din natin dito. Yan. So, bale, yung load ng slab, guys, okay, yung load sa slab natin is actually carried by the beam, di ba? So, for example, ano ba yung load sa slab? Now, since this is actually a slab, guys, yung loads natin usually in KPA, okay, or force per unit area. Kasi yung slab natin is an area man, okay? Kagaya nito, rectangular area. Okay, so siguro mga 5 kPa, 1.2 kPa or 2 kPa, depende na yan. But that is actually in per square meter, per square meter. Per area yan. Okay? And then that per area is actually carried by our beam. Now, our beam, alam natin na ang loads sa beam natin dito, it will be a distributed load. Okay? Now, depende na yan. May instances na varying, meron na instances na uniformly distributed. Now, for now, let's just consider na uniformly distributed yung loads ng beams. Again, itong loads na to, yung na color blue, again, colorblind kasi ako, so sorry if, I think blue naman ito. So, itong loads na to, this is actually from our slab. Okay, now, later on na lang, i-discuss ko kung bakit, gaya na sabi ko, pwedeng uniformly distributed or varying. Depende kasi yan sa slab natin. Meron kasing one-way at saka two-way slab. Okay? So, dito lang muna. Yan. Kay KL. Now, paano natin isosolve yung loads na to? Usually, guys, ang ginagawa natin is ganito. Ano nga ulit yan? Tama, yung slabs na. Sige. So, for example, ito yung slab natin, di ba? Ganyan. And then, we have the beams here. Yan yung beams natin dyan. Ilang beams ba yun kanina? 3 lang pala. 4 lang pala. Sandali ha, baguhin natin. Ganun na lang. So, yung slab natin, guys, usually, yun nga, gaya ng sabi ko, is ang load natin is in kPa kasi per unit area. Now, yung beams natin, notice na ang beams natin dito actually carries a uniformly distributed load. Tapos, yung uniformly distributed load natin is in kilonewton per meter, di ba? Kilonewton per meter. Now, paano to nangyari, sir? Paano matransmit yung load sa slab to our beam? Okay? So, usually guys, meron tayong tinatawag na tributary area. Later on na lang yan. Okay? So, dito guys, dito nag-assume siguro siya na one-way slab ito. Again, later on na lang. So, ang ginawa niya guys is simple lang. For example, ang load ng slab is 2 kPa. For example, ang loads ng slab natin is 2 kPa. Yan. That is actually 2 kilonewton per square meter, di ba? And then, ang beams natin is only carrying kilonewton per meter. So, this load, we need to multiply this load by a certain meter para maging kilonewton per meter para makancel out yung isang meter sa ibaba. So, ano yung dimension na gagamitin natin? So, yan guys, ang gagawin lang natin is kunin lang natin yung parang tributary width ng beam natin. Okay, so, for example, ito. For example, this beam. Ang kinakari ng beam na to, ang part ng slab na kinakari ng beam na to is ito lang. Yan. Ito lang. Ito yung part ng slab na kinakari ng beam. So, meaning, we just need to multiply that by this distance. Itong width na to, ito. Yung width na yan. Okay? So, for example, yung center-to-center spacing ng beams natin, siguro mga 5 meters or 3 meters. Okay? So, gamitin natin 3M. Yan, 3 meters. Okay? So, therefore, yung tributary width na yan, that is actually 1.5 meters. So, yung 2 kilonewton per square meter, we just need to multiply that by 1.5 meter. Okay? So, yun nga, depende na yan, guys. Okay? Depende na yan sa tributary width talaga. So, dito, guys, assume muna natin na one-way slab. Anyway, later on, meron tayong paraan on how to determine the tributary areas of our yung beams natin, tsaka yung iba pang mga structural members natin. But that is actually the case, no? Baka magtaka kayo kung paano matransmit yung load, okay, from the slab to the beam. Again, we just need to multiply that by a tributary width, okay, or area. Depende na yan. Yan. Okay, so kaya ganito yung nangyari. Okay, so itong loads na to, these are actually from the slabs. Okay, now gaya ng sabi ko, yung beams natin is actually now carried by the girders. Okay, so paano to, sir? Ano yung load ng girder? So notice na ang kinakari lang ng girder is yung beams, diba? So ang reaction ng girder, guys, is actually ganito lang. Tignan nyo. Sir, ano to, sir? Saan galing yan? Now, these are actually, itong yung, di ba, 4 no? 1, 2, 3, 4. Now, these are actually from the, di ba ito yun? These are actually the reactions of the beams. Now, assuming na simply supported, guys, makukuha nyo yan. Okay, simply get the resultant divided by 2. Makukuha nyo to. Okay, so yan na yung kinakari ng girders natin. So, yan. So, meron tayong concentrated loads. Again, those concentrated loads are from the reactions of the beams. Okay? And then, again, ano yung nagkakari ng girder? Ang girders, kinakari ng column. Okay? So, itong reaction na to, ito, di ba? Di ba meron dalawang reaction yung girders natin? Dito yan ilalagay sa column. Uy, nasaan yan? By the way, yun nga. Ito yun ha. So, yung beams natin, okay, dito yun. Okay, so yung reactions ng beams na to, this is actually carried by our girders. Yan. And then the reactions of our girders, ito, is now carried by our column. Yan, okay. So ito na yon. So, saan na yan? Yan. Again, yung reaction ng girders, tingnan nyo, is carried by the columns. Okay, and then yung reaction dito, obviously, same din yan dyan. So, yung columns naman, okay, yung load sa columns, yung axial load ng columns, is now carried by the foundation. Yan. So, ito, yung concentrated load dyan, that is actually from our column, which is from the girder, which is from the beam, and then which from the slab. Okay, so ganun yung transmission ng loads. And then lastly, our foundations na to, yung foundations natin will transmit the loads, okay, from the columns to the soil, okay, or yung ground foundation natin, footing pala. Yung footing natin will transmit the loads, okay, from the columns to the foundation, yung ground foundation natin, or yung soil natin. So, basically, ganun lang, guys. So, I think dito tayo magfo-focus. Ay, dito. Dito tayo mag-focus kung paano yung loads from the slab is actually transmitted from the beam. But generally, yan yung transmission ng loads natin. So, you cannot actually get the loads on the columns easily without solving for the loads sa beams. Ganon. Okay? Or sa girders. Ganyan. Same din sa foundation. Okay? So, anyway, dito siguro pwede, but sa mga complex na mga systems, mahirapan kang isolve yung mga excuse me, yung mga loads ng foundations ng columns without solving the loads beforehand, yung nasa girders and beams. Okay, so anyway, check out daw natin yung methods, no? Yung mga tributary areas na sinasabi ko. Yan. Okay, so this is actually a typical, parang meron tayong typical na floor system dito, floor plan dito. So we have yun nga, makikita nyo yung columns, yung girders, at saka yung beams. Okay? So anyway, we have ito yung columns natin, yan yung naka-eye na nakahiga. Okay, we have, yan. So meron tayong 1, 2, 3, we have 9 columns, and then itong blue, itong malalaking beams, this is actually our girders, yan. We have the exterior girder, tama. We have the interior girders, ito, interior girders. So, we have the exterior columns, and then we have an interior column dito. So, ito naman, itong vertical, yan. These are actually our beams. So, same din, ito. Beams din yan. Ito, beams. Okay? So, yun. Now, gaya ng sabi ko, we can actually calculate the loads sa beams depende, no, kung ano yung tributary area na makukuha natin from our slab. Now, depende yan, guys. Meron tayong tinatawag na one-way slab at saka two-way slab. Okay? But for now, hindi muna tayo mag-focus sa bending. Ang gagawin lang natin is, pag one-way slab, guys, okay, ang gagawin lang ninyo is just get the ratio of ito, meron kasing, ito yung, di ba, ito yung beam yan. Yan yung beams natin. Okay, so meron tayong spacing ng beams natin yung S1 dito. Dito sa part na to, ang spacing ng beams is S1, and then dito, ang spacing ng beams is S2. Okay? Now, ang gagawin nyo lang, guys, for this slab, halimbawa, itong slab na to, itong part na to, itong slab na to. So, sa slab na to, di ba, rectangular yan. So, meron siyang, ang length niya is actually ito. Ito yung L3, and then you have, yung width ng slab natin is actually, yan, S1. So, ang gagawin nyo lang, guys, is just ratio and proportion ka lang. Okay? So, i-divide mo yung length, yung malaki, L3 divided by S1. Okay? Pag ang sagot mo is greater than 2, okay, or equal or greater than 2, therefore, that is actually a one-way slab. Again, tandaan nyo ha, equal or greater than 2. Okay? So again ha, pag nag-divide ko, for example, yung L3 dito is actually siguro 6. Okay? And then dito yung S1 is 2. Okay? Or 2.5 or 3. So 6 divided by 3, that is actually 2. Therefore, since 2 yun, that meaning itong slab na to, this is actually, we can design this slab as one-way slab. So, ano yung mangyayari doon? Pag one-way slab kasi guys, yung tributary area ng slab na to, ito, you can actually cut, hahatiin mo lang yan. So, bali, i-draw natin dito. So, kung ganito yung slab natin kanina, and then this is actually 3 and 6, and then since 6 over 3 is equal to 2, okay, since that is equal to 2, that is actually a one-way slab. So, ang gagawin lang natin guys is just cut the slab. Yan. So, meaning, itong part ng slab na to, ito. Itong part ng slab na to is actually carried by this beam. Yan, sa beam na to. Ilalagay mo yan dyan sa beam na yan. And then, itong part ng slab na to is now carried by sa beam na to, dito sa kabila. Okay? So, anyway, check, tingnan ninyo. Yan o. Okay? So, for example, dito, tingnan nyo, itong part ng slab na to is actually carried by this beam. So, tingnan nyo, ito yung tributary area ng beam. Tingnan nyo, tributary area of exterior beam. So, itong beam na to is actually carrying this slab. Okay? Kasi nga, kalahati lang. Again, assuming na one-way slab to, although hindi nilagay yung dimensions. So, yan. And then likewise, itong beam na to, itong beam na yan. Ay, sorry. Hindi pala nakikita. Sorry. So, itong exterior beam na to is actually carrying this slab yan. Okay, kalahati lang. So, if this is S1, so meaning yung length na to is S1 over 2. Therefore, if gusto mong isolve, okay, if gusto mong isolve yung load sa beam na to, kunin mo lang yung loads ng slab. Okay, which is ibibigay sa problem siguro mga 5 kPa, 3 kPa, ganon. I-multiply mo lang sa tributary width. So, this is actually S1 over 2. So, for example, if this is 3, and then yun nga, gaya ng sabi ko, so 1.5 to. So, yung load na kinakari ng beam na to is actually 3 kPa times 1.5 meters. So, magiging, ano yan, 3 times 1.5, 4.5 kilonewton per meter. Okay? Uy, 3 times 1.5, hindi, tama ba? 4.5? Tama pala. Okay? So, I hope okay tayo ha? And then, likewise din, kung mapapansin nyo, sir, ano yung mangyayari, sir, pag ganito? What if, sir, what if, kagaya nito, yung nasa kabila, yung slab sa kabila is malaki, dito naman is maliit. Now, same pa din, guys. Yung tributary area ng beam na to is just half sa slab dito, and then half din sa kabila. And then, yung tributary width niya is ito na. Okay? So, bali, parang ganito yan. For example, lagay tayo dito ng beam. Same pa din, 3.6. Okay, and then, ilagay na lang natin siguro itong, sige, okay na yan. And then, ito, and then, 2. Okay? So, we are interested sa tributary area sa beam na to. So, ang gagawin nyo lang, guys, is check if this slab is actually one-way slab. So, 6 divided by 3, that is actually 2. So, since 2 or greater than 2, so meaning this is one-way slab. So, meaning, hatiin mo lang yan. Hatiin mo lang. And then, yung kabila, check mo din kung one-way slab ba to. So, 6 divided by 2, that is 3, which is greater than 2. So, therefore, one-way slab din. So, hatiin mo lang din to. Yan. And then, so meaning, ito na yung total tributary width ng beam na to. Okay? So, therefore, itong part ng slab na to is carried by this beam. And then, this part is actually carried by this beam. So, sir, paano ko kukunin yung load na kinakari ng beam? So, simple lang. To solve for the load, kunin mo lang yung dimensions na to. Okay? Di ba this is actually 1.5, this is 1. Okay? So, again, for example, if 3, okay, if 3 kPa or 3 kPa or 3 kilonewton per square meter yung load na kinakari ng slab. So, pag i-transmit natin yan sa beam, ang load na ikakari ng beam is, gaya ng sabi ko, is in kilonewton per meter. So, we just need to multiply that by, okay, i-multiply mo lang yan by the tributary width ito. This is actually 2.5. Okay, sorry. Yan. 2.5 meter. Okay? So, therefore, ano to? 7.5. Okay, so meron ka lang 7.5 kilonewton meter load para sa beam mo. Okay? So, I hope okay tayo dyan, ha? Yan. So, check na natin dito ulit. Yan. Okay? So, same din dito. Tingnan nyo. Same lang din dyan. Okay? So, ganyan yung tributary tributary areas na kinakari ng beams natin. Provided na one-way slab. Ang two-way slab, sa next slides muna. Okay? Check natin. Meron tayong mga tributary areas din para sa columns at saka para sa girders natin. For example, gusto mong kunin yung, yan. So, kung kukunin mo yung tributary width, ito. Yan. Diba? So, ito yung halimbawa, ito yung girder natin. So, ang tributary area ng girder, guys, is just same pa din. Kalahati lang. Check nyo lang yung spacing ng girder. Okay? I-check nyo lang yung spacing ng girder. For example, draw ko na lang dito. Paano ba yung figure natin dyan? So, parang ganun, no? So, di ba ito yung spacing ng girders? Yan. By the way, ito yung columns natin, di ba? Columns. Sorry. Columns. So, ito yung spacing ng girders. Okay? Yan yung spacing ng girders. So, to get the tributary areas of the girders, same pa rin, guys. Hatiin mo na lang. Now, by the way, you do not need to check if one-way slab or two-way slab pag girders. Sa beams lang yan, i-check mo. Pag girders, guys, automatic, just hatiin mo lang. Okay, so, hatiin natin dito. Okay, so again, ito na yung tributary. Balik na dito, yan. Ito na yung tributary. Yan. Yan na yung tributary width ng girder na to. Ito. Okay? Likewise, ito din yung tributary width ng girder. Ito. Ito pala. Tributary area ng girder na to. Yan. Okay? So, yung para sa girder na to, guys, itong malaking girder na to. So, ito yung tributary area niya. Itong mas malaki. Yan. So, yan. Okay? So, I hope okay tayo, ha? So, check na natin dito ulit. Ayan, o. Now, so, same din para sa girder na to. Ito yung tributary area niya. Okay? So, I hope okay tayo dyan. Okay, now, again, guys, although alam mo yung tributary area ng girder, hindi mo agad masusolve yung loads ng girder from the tributary area. Again, ano yung gagawin mo? Well, masusolve mo siguro, makikita natin mamaya, no, na makukompare natin, machi-check natin kung tama ba yung loads natin from the tributary area, but hindi agad-agad. For example, from the tributary area, kunin mo yung loads ng girder. Hindi. Okay? Kasi nga, yung loads ng girders, hindi yan from this, hindi mo makukuha from that area kasi yung girder natin hindi naman nagkakari ng slab. Okay? Ang kinakari niya is actually yung beams. Okay? So, sir, bakit mo kami tinuruan kung ano yung tributary area ng girder? So, makikita nyo mamaya kasi ma-check natin kasi dapat yung total load na kinakari ng girder natin, okay, must be equal to the total load carried by this slab. Ito, sa part ito ng slab. Okay? So, anyway, ma-check natin yan mamaya. So, if gusto mo lang yung total load na kinakari ng girder, meaning yung resultant ba? Di ba kanina, ikita nyo, yung girders natin, nagkakari ng 1, 2, 3, 4 na concentrated loads. So, dito, check natin kung ilan yung concentrated loads. So, for this girder, tama, no? 4 din yung concentrated loads. So, kung gusto mong kunin yung resultant ng 4 na concentrated loads, just get the area of this, yung tributary area na to. And then, just multiply that by the slab. For example, paano ba to? By the load sa slab. Ganito na lang. Ito na lang. Example natin to. Yan. Asa na yun? Ito na lang. I think mas maganda sa figure. Tama. Yan na lang. So, gandahan na lang natin para balik tayo dito. Yan, gandahan natin. For example, di ba yung girder na to, this is actually yung nasa itaas. I-draw natin ulit. Sorry. Okay? And then this girder is actually carrying itong beams na to, ito. Yan. Isa, dalawa, tatlo, and then apat. Okay? Now, ito. Lagyan lang natin dito. Itong girder na to, pag ilalagay natin dito, so yung parang isometric niya is parang nagkakari siya ng apat na, di ba? Reactions or apat na concentrated loads from our beam. Diyan. Okay? With this, yan. From our beam. Now, ang apat na to, for example, this is, tawagan natin A, yung mga loads natin. So, yung loads na yan, huwag na lang A, medyo pangit. So, yung resultant ng apat na loads na yan, so in a way, makukuha mo natin yan pag i-add mo. Pag i-add mo yung apat na loads na yan, that is just equal, okay, to the total load carried by this part of the slab. Ito. Di ba? Kasi ito yung tributary area ng girder. Later on, meron tayong example problem para mas ma-imagine ninyo. So, di ba ito yung tributary area ng girder? Okay? Yan yung tributary area ng girder. So, yung resultant ng apat na yan is just equal to the load carried by this slab. For example, yung slab natin dito, this is actually, siguro, this is 6, ganyan. Okay, sorry. Hindi pala 3 times 4, that is actually, 3 times, this is actually 9 meters, yan. For example, 9 meters yan, and then ito, this is actually now 3 meters, yan. So, 3 times 9, that is actually 27 square meters, di ba? So, kunin mo lang yung load ng slab. For example, yung loads ng slab natin, yung load ng slab is 3 kPa, so 3 kilonewton per meter, square meter, di ba? And then, yung resultant, yung apat na to is just equal to the 3 kilonewton per meter. Multiply mo yan sa area ng slab na to. Ano yung area niyan? 27 square meter. And then, yun nga, makukuha mo to. Okay? So, as a checking lang talaga. Okay? So, pag same lang to, pag ito, okay, at saka yung total ng apat na to is just the same. So, meaning, tama yung sagot mo. So, bale, na-check lang natin from our tributary area. Okay? So, anyway, I think meron tayong mga example problems mamaya para mas maintindihan ninyo. Okay? So, balik tayo dito. So, again this is just a checking. So, meaning, gaya nito, for example, itong girder na to. Di ba itong girder na to is actually carrying 4 concentrated loads? Well, actually, 8 kasi nga reaction dito, reaction sa beam na to. Pero, makombine man yung reaction. Okay? So, anyway, dito sa girder na to, 4 lang yung ikakari niya na concentrated loads. So, yung from the reactions of these beams, ito at saka ito. Yan. So, and then, kung gusto mong check if tama, kung gusto mong i-check kung tama ba yung sagot mo, so, ang gagawin mo lang is kunin mo yung resultant sa concentrated loads that is carried by the girder. Okay? And then, kunin mo yung sum doon, and then, just check. Kunin mo daw yung, yung loads, total loads na kinakari ng slab na to. So, kunin mo yung area, tributary area, and then multiply that with the loads carried by the slab. Okay? So, likewise, sa columns din, guys, same din. Actually, meron din tayong tributary area sa columns. Now, pag columns naman, guys, ang titingnan din natin is actually spacing lang din ng mga columns. For example, ito. Baka isipin nyo, sir, itong column na to, ito yung tributary area. Paano itong column na to, sir? Ito yung tributary area. Again, medyo pangit tingnan kasi sa drawing kasi kasali yung mga beams, ganon. So, try na natin i-draw ulit na columns lang talaga yung nandun. Ay, medyo mali. Sandali. So, from the figure, medyo ito malayo and then ito malapit lang. Ganyan. Okay? So, pag ganyan, guys, mas makikita na natin kasi ang gagawin lang natin is, tingnan nyo lang yung spacing ng columns, di ba ito? So, hatiin nyo lang to. Yan yung spacing ng columns natin. Dito din, hatiin nyo din. Okay? Vertical yan, ha? And then, yung horizontal spacing niya, siguro, ganito din. Okay? So, same din dito. Therefore, guys, ganun lang. Okay? So, meaning, itong column na to, itong column na nasa nandito, is actually carrying this tributary area. Now, itong column naman na to is actually carrying this tributary area, while the other ito, ganun. Okay? So, I hope okay tayo, ha? Ganun lang. So, kung mapapansin nyo dito sa figure, tingnan nyo, di ba? So, itong column na to is actually carrying this tributary area. Ito is kalahati ng L1, and then ito is kalahati ng L3. Okay? So, actually guys, same din. Same din. To check if tama ba yung loads sa column mo, okay? Just get the tributary area of the column and then multiply that by the tributary area ng column and then multiply that by the load carried by the slab. So, dapat same lang din yung makukuha mong reaction dito by yung mano-mano ba, yung from the, kunin mo yung slab to the beam and then beam to the girders and then yung total reaction sa girder, di ba? Yan yung load na kinakari ng column. Another way to check, okay, kung tama ba yung nakuha mong reaction sa girder is just directly get the load in the column by using the tributary area. Kung same lang ba sila. Kung di sila same, therefore, meron kang mali sa loads mo sa girder, yung pag-transmit mo sa loads. Okay? So, I think same lang, no? So, after nyan, once meron tayong tributary area ng column, so from the columns, yun nga, ilalagay natin sa foundation. So, ano ba yung sunod na slide dito? Tama. Dito na papasok yung what if two-way slab. Now, ang two-way slab, guys, mangyayari, of course, di ba kanina, kung kung ang ratio ng longer span to the shorter span is equal or greater than 2. Now, ang two-way slab, guys, is if less than 2. Okay, for example, okay tayo dito. For example, this is actually, yun nga, halimbawa, yung slab natin is merong square na dimensions. You have 3 and 3. Okay, or siguro mga 4x4, 5x5. Okay? So, again, 5 divided by 5 is 1. Okay, so therefore, that is actually less than 2. So, ano yan? Two-way slab. Now, for example, this is 3. And then, ito is, taasan natin ng konti. 5. Okay, so 5 divided by 3 is actually less than, okay, less than 5 divided by 3. Naku, nabubo na ako, guys. Yan, 1.67. So, 1.67 is less than 2. Okay? So, therefore, that is actually a two-way slab then. So, ano yung mangyayari, sir? Ano yung mangyayari, sir, pag two-way slab? Now, pag two-way slab, guys, hindi mo pwedeng, hindi ganito yung tributary area. Okay, hindi ganyan yung tributary area. So, ang mangyayari, guys, sa two-way slab, usually kasi dito, beam to, ito, beam din dapat to dito. Okay, ito ba? Beam and then beam din to. Ang mangyayari, guys, is, ang slab na to, ang part ng slab na to, guys, is actually carried by this beam. Ang part naman dito is actually carried by this beam. Ito, carried by, ito, beam na mas malapit, and then lastly, ito, is carried by the beam dito. So, paano yan mangyari? So, parang ganito yan. Yan. So, to do that, tinan nyo, itong slab na to is actually carried by this beam. Yan. Okay? Same din, itong slab na to is carried by this beam. Itong slab na to is carried by this beam. Ito, carried by that beam. Sir, kailangan ba talaga, sir, na ganito? Kailangan ba talaga, sir, na parang triangular? No, hindi, ha? Baka isipin nyo kasi, for example, sir, what if, what if rectangular, sir? So, ganun ba yun? Ganun ba, sir? Ganun ba yun talaga? Ganyan ba? Ay, sorry. Ganyan ba talaga yung orientation? Hindi, ha? Ang nangyari lang to dito, okay? Sa figure na to, kasi nga, this is actually a square. Pag square kasi, it so happen na lahat triangular. Now, pag rectangle, tingnan nyo, square kasi ito kasi L at saka L. So, same yung sides niya, kaya square to. Kaya naging triangular lahat ng kinakari na slab. Now, what if rectangular? Pag rectangular, guys, iba yung usapan pag rectangular. Pag rectangular naman, halimbawa ganito, pero two-way slab pa din, ha? So, siguro, again, this is 3. Ay, sorry. This is, bakit? Trapezoid na yan. So, this is 3 and then this is actually 5. So, hindi pwedeng ganito yung pagkakahati. Ganyan yung tributary area. Hindi. So, to do that, guys, yung pag Okay? Pag-determine ng tributary area, just create a 45-degree diagonal sa edges ng slab mo. So, for example, dito, dyan. Ito yung mga edges, di ba? Yan. So, create a 45-degree diagonal. So, 45 degrees. Yan. So, dito din, 45 degrees din. Uy, bakit hindi sila nag-meet? Yan. Same din dito, 45 degrees. Tama ba? 45 degrees ba to? And then dito din, 45 degrees din. Okay? Yan. So, basically, instead of Instead of triangular lahat, kung mapapansin nyo guys, ang longer span is actually carrying a trapezoidal tributary area. So, yung tributary area nito is, ng 3 meter beam. Yung 3 meters na beam is ito. Same din, yung tributary area nito is actually ito. Yan. Okay, so I hope okay tayo ha. Same din, yung tributary area nito is ito din. So, anyway, ang tandaan nyo lang is 45 degree. Ito lang, 45 degree. Yung 45 degrees na, okay, diagonal for every edges. Okay? Ganun. So, pag ganyan. And then, para hindi pa kayo mahirapan, tandaan nyo lang, yung shorter span, okay? Halimbawa, di ba ito yung slab, 5 by 3, di ba? So, obviously, yung shorter span is yung 3 meters. Yung shorter slab will always carry a triangular load. Unless, of course, kung equal lang sila, lahat triangular. Okay? Yan. So, sir, paano na yan, sir? Ano na yung load na kinakari ng, okay, ano na yung load na kinakari ng beam na to? So, same din. Sorry. So, ang load, guys, na kinakari ng beam is actually WL over 2. Sir, ano yung W? Again, yung W is actually the intensity of the load carried by the slab. So, siguro 3 kPa, ganon. So, for example, if that is 3 kPa and then yung length natin is same pa rin 2 or 3. So, 3 times 3 over 2, that is actually 4.5, diba? 3 times 3, 9. So, divide by 2, 4.5. So, meron ka lang triangular load. I'm sure kaya mong isolve yan. Meron ka lang triangular distributed load. Okay? So, again, ano yung load na kinakari nito? WL over 2, provided na ang W must be in kPa, or W is actually from from the load from the slab. Okay? So, yan lang yung pinagkaiba. Okay? Kaya sinabi ko sa inyo na maaaring yung kinakari ng beam is not actually a uniformly distributed load. Pwede din actually varying load, depende sa slab natin. Okay? So, always check guys kung one-way ba or two-way slab. Again, how can you check for that? I-divide nyo lang ang longer span sa shorter span. If equal or greater than 2, one-way slab. Actually, madali yung one-way slab kasi hindi na tayo mahihirapan, no? And then, but yun nga, pag two-way slab, always check. Okay, so pag two-way slab, yung longer span divided by the shorter span is actually less than 2. Okay, so yan yung pagkuha ng P. So, same din dito. Tingnan nyo. Walang pinagkaiba guys ha. Yan. Okay. So, anyway, tingnan nyo dito. So, walang pinagkaiba. Ang intensity ng slabs natin dito is just the same ha. Tingnan nyo, WL2 over 2. Ito din, WL2 over 2. Okay. Again, shorter span ha. Yung shorter span yung ginagamit natin. Yan. So, I think mas maganda guys kung meron tayong example problems. Check ko daw mamaya. Check ko daw dito kung meron tayong example problem. Tama. So, let's try to answer daw itong example problem natin and then i-apply natin yung natutunan natin. Now, sa two-way slab, I think yung example problem ko is only for one-way slab. Anyway, meron tayong example problem sa two-way slab. Ibibigay ko na lang as a handout. Okay? So, check out natin yung example problem natin. Yan. So, the floor of a building now is subjected to a uniformly distributed load of 3.5 kPa over its surface area. So, again, yung load na kinakari ng slab natin is 3.5 kPa. Okay? Determine that the loads acting on all members of the floor system. Now, the members of our floor system, kung mapapansin nyo, meron tayong tatlong members na. We have beams, we have the girders, and then the column. Of course, wag na natin isali yung slab kasi binigay naman yung load slab na 3 kPa. So we need to determine the load sa beams, sa girders, and sa column. Again, to do that, i-check nyo muna, di ba? First, dadaan muna tayo sa beam. Okay? So anyway, ilipat ko muna to, yung problem natin. Ilipat ko muna guys, ha? I think pwede na ata natin hindi na lang ilipat. Sige, sige. So, anyway, we have our slab dito, no? So, ito yung slab natin. And then, meron tayong apat na beams. Isa, dalawa, tatlo, apat. Diba? A, B, C, D, E, F, and G, H. So, first guys, let's try to solve the load at beam AB. So, to solve for the load at beam AB, so i-draw ko dito. So, bale, ganito, no? So, this is our beam AB. Yan. So check muna natin guys kung ang tributary area ng AB is pag ganito ba? Okay, ito ba yung tributary area ng beam AB or kung ganito ba yung tributary area ng beam AB? Okay, pag ganyan kasi iba din yung load na kinakari ng beam AB. So to check for that, check natin kung one way ba or two-way slab. So this is actually 3 at 4 meters. Ang ibig sabihin nun ha is itong tatlo na to, di ba? 1, 2, 3. Tatlo yung spacing dyan. So that is actually per 4 meters. So yung total is 12 meters. Okay, so meaning 12 divided by 3, that's actually 4 meters. Okay, so 4 ito, and then this is actually 9 meters. So let's divide 9 by 4, di ba? Long, kasi ganito yun eh. Yan, 9m, and then this is actually 4 meters. Okay, so divide that. Let's try to divide down. 9. Ano ba yung 9 divided by 4? 2.25, okay? So 2.25 is actually greater than 2. Therefore, safe tayo, no? This is actually one-way slab. Okay? So kung 2 pa yan, same pa din, one-way slab pa din. But if ever less than 2, that is actually now two-way slab. So since one-way slab lang to, so you just need to, yan, hatiin mo lang yung shorter span yan. So ito na yung tributary area ng beam natin. So this distance is actually now, 2 meters. And then yung load ng slab natin is actually 3 kPa, di ba? 3 kPa. So to solve for the load on our beam, di ba? Ito yung beam natin. Yan. So yung load ng beam natin is rectangular din kasi rectangular man yung tributary area. So yung load ng beam natin guys is simply equal to 3 kilonewton per meter square. Okay? Multiply that by the width, tributary width ng tributary area natin. Okay? So, yung tributary width ng beam is actually 2 meters. So, 2m. So, that is actually 6 kilonewton per meter. Okay? So, yung kabila naman, yung beam CD. Okay? Check na natin yung beam CD. Yung beam CD, guys, from our figure here, kung mapapansin nyo, yung beam CD is ito, no? Dalawa yung tributary area na dinadala ng beam CD. Yung kalahati sa itaas at saka yung kalahati din dito sa ibaba. So, kung i-drawing ko to, parang ganito yung beam CD natin. If this is our beams CD, so yung tributary, ilagay ko na lang dito. Diba? This is actually 9 meters and then this is 4 meters. Same din, 4 meters din to. So, ang tributary area ng beam CD is, nakuha natin na this slab is actually one-way slab. So, hatiin lang natin. Same din, since same lang yung nasa itaas, this slab is also a one-way slab. So, hatiin lang din natin. Yeah. So, ito na yung tributary area ng beam CD. So, yung tributary width niya is the sum of these two. So, that is actually 2m and then 2m dito. So, 4 meters lang din to. Okay? So, to solve for the load at beam CD, yung kunin mo lang yung 3.5, multiplied mo lang by, 3.5 pala yung load natin. Ba, saan galing yung 3 meters ko? 3 kilonewton per 3 kPa ko kanina. 3.5 pala to, sorry. 3.5 kPa. Okay, so this is actually, nawala. Sorry. Iba naman yung nawala. 3.5. So, instead of 6 meters, this is actually 7 kilonewton per meter. Okay? So, meaning, yung nasa ibaba, yung load ng beam CD natin. So, the load at beam CD is simply equal to 3.5 kPa multiplied by 4 or kN per square meter multiplied by 4 meters. Okay, so this is actually 14 kilonewton per meter. Okay, check na natin dito. Di ba? So, yung isa, we have 7 kilonewton per meter for beam AB. And then yung EF naman is actually 14 kilonewton per meter. And then, to solve for the reaction, guys, walang problema. I'm sure kayang-kaya nyong i-solve yung reaction, di ba? So, yung reaction natin is actually, yan, 7. For example, sa beam AB, yung reaction natin is 7 times 9, just divide that by 2. Okay, so we have 31 kilonewton. 31 kilonewton din dito. Sir, bakit mo sinolve yung reactions? Importante yung reaction, guys, kasi itong reactions na to, ito yung ikakari ng girders natin. Okay? So, sir, bakit yung beam AB lang at saka yung beam EF ang sinolve mo? Bakit hindi mo sinolve yung beams EF and beams GH? Now, obviously, beam EF is just the same as beam CD. Symmetrical, di ba? Symmetrical yung beams natin dito. So, walang problema. Same lang sila. Okay, so kung ano yung load sa beam CD is just the same as beam EF. And then kung ano yung load sa beam AB, same lang sa beam GH. GH pala. Yan. Okay? So, anyway, nakuha na natin yung loads sa beams. Now, by the way, guys, baka magtaka kayo, sir. Ano tong nasa figure, sir? Bakit meron ganyan? So, anyway, later on na lang yan. Ito kasing strip na yan. Yung strip na yan, that is actually for our pag nag-design ka sa yung bending ba, okay? Pag nag-design ka sa slab mo, I think ito yung ibig sabihin ng 1 meter dito. 1 meter strip. Okay? Per 1 meter strip. Yeah. Anyway, yan yung load per kilonewton per meter. So, hindi ko alam bakit may 1 meter strip dito. Anyway, proceed tayo sa next. Yung loads ng girder. So, sa loads sa girder, guys, balik tayo sa figure. Yeah. So, ang girders natin, we have two girders, no? We have girder AG and BH. Okay? So, i-draw ko muna yung girder BH. So, draw natin yung BH. So, sorry. So, ito yung girder BH. Yan. And then, ito, BH. Now, notice guys, nasa girder BH, ang kinakari niya is yung beams AB, CD, EF, and GH. But, kalahati lang, di ba, dito? So, ano yung reaction dito nga? Ano nga ulit yung reaction sa beam AB? Okay, so check natin ulit sa solution natin. So, yung reaction sa beam AB, guys, is actually 31.5 kilonewton. Therefore, asan na ulit yung figure? Okay, so beam AB. Okay, so tama lang. So 31.5 kilonewton. So this is actually now 31.5 kilonewton. Okay? So same din. So 'di ba, yung beam AB natin, balik tayo dito. Okay? So yung beam AB natin 31.5 is ang reaction sa B. So alam din natin yung reaction sa beam GH, 'di ba? So same lang sila. So meron din tayong 31.5 dito. Okay? 31.5. And then same din dito, meron siyang dalawang reactions from our beams. Ano yung beams natin? From our beams CD and EF. Okay? So ano yung reaction sa beam sa D? Yan, sa D. Check na natin ulit. 63 kilonewton, di ba? 63 kilonewton. So check na natin. Lagay lang natin 63 kilonewton dito. 63 kilonewton. Likewise, this is still 63 kilonewton. Okay? Now, with that guys, pwede natin isolve yung reaction sa girder. So, ito na actually yung loadings para sa girder BH. And then, let's just solve the reaction of our girders para alam natin kung ano yung load na ilalagay natin sa columns natin. Okay? So, ano yung reaction nito? 31.5 times 6. 189, tama ba? 31.5 times 2 plus 63 times 2. Yeah, 189 and then divide that by 2. Tama, 94.5. So this is 94.5 kilo Newton. Okay? So, I hope okay tayo dyan ha. Now, again guys, gaya ng sabi ko, to check if tama ba yung reaction ninyo na 94.5, you can actually use the tributary method, yung tributary area. So, balik tayo sa figure. Ano yung tributary area ng beam BH? I mean, ng girder BH. So, ang tributary area guys ng girder BH is, di ba ito? I-draw ko ha. So, yung tributary area ng girder BH is, ano yung figure natin? We have 9 at saka 12, no? So, this is actually 9M and then this is 12M. Now, I hope you agree, no, na ang tributary area ng beam BH, I mean, ng girder BH, is actually ito. This is BH, di ba? So, ito yung tributary area ng girder BH. Yan. So, ito. So, yung nakuha natin, ano yung resultant ng apat na loads? Okay? So, yung apat na loads natin is actually 31.563 and then yun nga, symmetrical man lang, yung isa 63, 31.5. So, yung resultant niya from our calculations is 189. So, to check if tama ba yung nakuha natin na total load na kinakari ng girder, just use the tributary area. So, yung tributary area natin is 12 by, obviously, this is 4.5 meters. Kasi nga, 9 meter kasi yung nasa ibaba. Okay? So, check, dapat 189. So, ano yung load na kinakari ng slab? 3.5 kilonewton per square meter. 3.5 kPa. Multiply that by the tributary area of the girder. So, that is actually 4.5 meters multiplied by 9 meters. Okay? Ay, 12 meters pala. Sorry. 4.5 multiplied by 12 meters. So, check na natin. 3.5 times 4.5 times 12. Di ba? 189. So, meaning, tama yung sagot natin. So, nagamit pa din natin yung tributary areas ng girders at saka ng girder natin, but that doesn't mean na yan yung ginamit natin to solve for the loads. Hindi. Ginamit lang natin yung tributary area as a checking lang. So, importante pa din na alam mo yung tributary areas ng girders at saka ng columns. Now, ito yung maganda. We are trying to solve for the reaction yung load sa columns natin. Now, kung mapapansin nyo, from our answers dito, so, anyway, check muna natin yung solution dito. Okay, see? So, yun yung, ito yung load ng girders natin, 94.5. Now, yan, ito pala yung apat. So, ito yung reactions ng girders. Now, obviously, itong reactions ng girders, yung 94.5, yan yung reaction sa columns. Yan yung loads sa columns. So, itong 94.5 is carried by column dito. Okay, column A. Yung isa namang 94.5 carried by column G. Yung, of course, di ba, symmetrical man lang sila. So, dito, 94.5 din. 94.5 din dito. Okay? So, yan. So, yung load ng column is 94.5. Now, another way to solve for the load ng column, okay, instead of solving for the loads of columns using the loads sa girders, yung reactions sa girders, you can actually just use the tributary area of our column. Yan. So, 3.5 kPa, di ba? Ano yung tributary area ng column? That is actually 4.5 times 6. So, 3.5 times 4.5 times 6. So, that is actually 94.5. Tignan nyo, same lang. 94.5 lang din. This is actually the reaction sa girder. So, you can actually still use that. Okay? So, walang problema ha. Same lang sila ng makuha ang sagot. So, anyway, I hope meron kayong idea on how you can actually transmit the loads. So, check out na natin yung next slides. Yeah. So, once alam mo na kung anong pag-transmit ng loads, then you can actually now analyze yung beams or yung girders mo. Now, before that, baka isipin nyo, sir, yan lang ba talaga yung mga loads? By the way, guys, yung loads na in-apply natin kanina, I think basic load lang yun, yung service load yun. Okay? Now, meron tayong mga tinatawag na dead loads at saka meron din tayong mga tinatawag na live loads. Okay? Ang dead loads, guys, ito. So the dead loads are actually dead loads consist of the weights of various structural members and the weights of any objects that are permanently attached to the structure. So actually guys, kulang yung sagot natin kung balik tayo dito sa problem, example problem. Ay, sorry. Yeah. So actually, although sinabi dito guys na the floor of a building is subjected to a uniformly distributed load of 3.5 kPa over its surface area, determine that the loads acting on all members of the floor system. Actually, determine the loads acting on all members of the floor system from the given load lang. Ito lang, na 3.5 kPa. So if kukunin mo talaga yung load, okay? For example, sa whole structure, you must always consider, especially pag nag-design ka na, you must always consider the dead loads. Kasi yung beam mismo, kahit hindi mo palagyan yan ng loads, ng 3.5, I mean yung beam mismo, kahit wala pang load yung slabs, okay? Kinakarin niya na mismo, yung slab mismo, may sarili niyang, may weight. Di ba yung slab is, for example, concrete slab. Di ba mabigat yung slab natin dyan? So kinakarin na yan agad ng beam, kahit hindi mo palagyan ng 3.5 kPa yan. Okay, na load. Okay? Yung beam mismo kahit wala kang nakapatong dyan, yung weight mismo ng beam, yung weight mismo ng concrete, okay? Sarili niyang weight, kinakari niya, load na niyan. Okay? Load na yan, automatic. So, dapat sana nun, kinuha mo na lang natin dito. So, anyway, hindi man sinabi. So, kaya, ito lang yung ginamit natin. So, typically guys, ang beams, meron talaga siyang sarili niyang load. And then, ang dead load guys, for example, beams at saka beams, girders, ganun. So, uniformly distributed ha? For example, dead load. Okay? Ang dead load guys, sa beams, girders, uniformly distributed lang. Unless of course, pag ang beam mo is actually, parang, iba yung cross-section ba? Iba-iba yung cross-section all throughout its length. So, siguro mas mabigat yung sa left part kaysa sa right part. But generally, same cross-section man lang sila all throughout. So, same lang din. So, for example, meron kang beam. Ganito lang. Saan na yan? Ito. Beam AB. Diba? Kanina, yung load na kinakari ng beam AB is from our slab only. Okay? Okay. So, for example, again, yung beam natin, beam AB. Yan. Okay, sorry. Uy, ba't lumiit? Yan. Di ba kanina yung beam AB is actually carrying a load with an intensity of, 7 kilonewton per meter? 7 kilonewton per meter. Now, that load, guys, is actually from the slab. Now, dapat, guys, yung beam mismo, beam AB, is actually carrying another uniformly distributed load na i-add natin dyan sa 7 kilonewton per meter. Okay? And then, that load is actually our dead load. Now, how can we solve for the dead load that is carried by the beam? Now, usually guys, madali lang kunin yung dead load kasi nga na innate kasi yan sa beam. Okay? For example, yung beam natin is concrete. Okay? Tapos dapat bibigyan ka ng weight mismo ng concrete. Without the weight of the concrete or without the weight of the material, hindi mo masosolve yung dead load, di ba? Kasi nga, the dead load is from the weight itself sa structure. So, usually, typically, yung weight ng beam natin, ng concretes, or yung steel, I think binigay ko dito, yung list of common yan. So, we have, pag concrete guys, 23.6. Tingnan nyo, kilonewton per cubic meter. Yung ibibigay ha, hindi yung weight. Unit weight yan. So, I think familiar na kayo no, sa unit weight. So, for every 1 cubic meter, so 1 kilonewton yan no? So, meron siyang 23.6 kilonewton. Yan yung weight. So, 23.6 kilonewton per cubic meter. Now, same din, for example, meron ba tayong steel? Tama. Pag steel, 77 kilonewton per cubic meter. Tapos pag wood, and then aluminum at saka brick. Now, wag nyo, baka isipin nyo, sir, always ba yan, sir, na 23.6? Now, usually, guys, ibibigay yan dapat sa instructor ninyo. Unless, pag hindi binigay, dapat kayo yung mag-assume, pag concrete. Kasi iba-iba kasi yung iba, binagamit sa concrete, 23.6, yung iba, 24. Okay, so yun nga, dapat ibibigay talaga yan sa instructor nyo. But pag hindi, so ito na lang yung gamitin niyo. 23.6 pag concrete, 77 pag steel. But pag, I think ibibigay man dapat yan. Now, ang problem dito guys is, sir, ang binigay na load is unit weight, kilonewton per cubic meter. But, ang load ng beam, sir, is kilonewton per meter. Di ba? Sobra. Kasi, kilonewton per cubic meter. So, dapat, magiging kilonewton per meter yan. So, ano yung i-multiply natin? Notice na, we need to multiply this by a certain square meter para maging kilonewton per meter. Di ba? So, ano yung square meter na yan? Now, that square meter is actually the cross-sectional area of the beam. Okay? So, hindi mo masosolve yung dead load pag wala kang unit weight at saka wala ka ding cross-sectional area of the beam. Okay? So, pag meron ka ng cross-sectional area of the beam, then you can actually solve the... Okay? So, dapat meron kang cross-sectional area sa beam. Pag wala kang cross-sectional area sa beam, then you cannot actually get this uniformly distributed load. Okay? So, I think yan lang ata. Paano ba? Ano pa ba meron? Beam, girders. Now, sa column, wala din problema. Walang problema. Tama. Sa slab. Sir, what if slab, sir? So, yung slab kanina, sir, balik tayo dito. Saan yun? Sir, ibig sabihin, sir, yung slab kanina mismo, yung 3.5 kPa, hindi yan from the weight of the slab. Now, this is not from the weight of the slab, ha? Siguro, service loads lang to from the... Ang tawag dun? Tama. Hindi kasali yung dead load dito from the slab. Now, how can we solve for the dead load of the slab? So, same pa din, guys. Kunin mo yung material sa slab. Kung ano man yung slab, for example, concrete, okay, and then just get the load. Now, again, ulitin ko, yung load sa slab, okay, yung load sa slab is in kPa or per unit area. Okay? So, again, yung property ng material mo is unit weight, di ba? Kilonewton per cubic meter. And then, yung load sa slab is in kPa. Again, guys, ulitin ko, pag slab, kPa or kilonewton per square meter. And then, pag beam naman, kilonewton per meter. Okay? And then, pag column is kilonewton. Alam natin yan. So, pag slab, di ba? Dapat, kailangan natin ng kilonewton per square meter. So, we need to multiply this by a certain meter para maging kilonewton per square meter. Diba? Yung unit weight ng slab, for example, concrete na 23.6, we need to multiply that by a certain meter para maging kPa. Ito na yung load. Ito na yung dead load ng slab natin. Yan na yung dead load sa slab natin. Okay, so sir, ano itong meter na yan? Ano yung dimension na yan? So, actually, ang dimension na yan is the thickness of the slab. Okay? Kung kanina ang beam, di ba? We need to multiply the unit weight to the cross-sectional area of the beam. For example, ang beam mo is 400 by 500 mm. So, yeah, dyan mo i-multiply. But, pag slab na, guys, instead of multiplying that by the cross-section of the slab, since ang load sa slab is in kPa, so just multiply that by the thickness of the slab. So, usually, bibigay din yan dapat sa problem if involve yung dead load sa slab. Okay? So, siguro yung thickness sa slab, 100, 125 mm, depende na yan sa problem. Okay? So, ang mangyayari, guys, may mababago dito. For example, yan. Yung beams mo, madadagdagan yung load. Okay? Dahil nga, meron tayong another uniformly distributed load. Kaso nga lang, in this problem, we cannot actually solve kasi walang cross-sectional area yung beam. Same din dito. Okay? Yung girders mo, instead of a concentrated load, so ang girder mo ngayon, hindi nakita. So, ang girder mo ngayon, guys, hindi na ganyan yung load. So, ang loading sa girder is, well, ganun pa rin, but may madadagdag. Ano yung madadagdag? Maliban sa concentrated load, 4 na concentrated load, di ba? Merong 4 doon from the beams, meron din tayong uniformly distributed load. Saan galing yan, sir? That is actually from the dead load or the weight of the beam itself or weight of the girder. Okay? So, don't worry guys, let's just assume na same ang cross-section all throughout sa beam natin. So, uniformly distributed load lang yung load. Okay, so I hope okay tayo dyan. So, this is now in Kn per M. So, obviously, madadagdagan din yung load sa columns. Okay? So, anyway, another type of loading guys is we have our yung live loads. Now, yung live loads, I think later on na lang tayo, sorry. Yung live loads, these are actually loads that can vary both in magnitude and location. So, maliban sa mag-iiba yung magnitude niya, mag-iiba pa yung location niya. Pwede siyang gagalaw ba, hindi lang siya stationary. So, anyway, these loads, usually, I think familiar ka no, sa mga loads sa bridges, di ba? Yung mga vehicular loads natin, gumagalaw kasi yung mga vehicles. So, yan, that is actually an example of live load. So, anyway, sa later topics na lang yan, especially pag meron tayong influence diagrams. So, I think yan lang muna guys. And then, para sa next topic na determinacy and stability of beam, siguro sa next video na lang. So, yan lang ata. And maraming salamat sa panonood. I hope na may natutunan kayo in the translation of loads from our structures. From the beam, from the slab to the beam, beam to the girder, girder to column, and then column to foundation. Footing, and then footing to the soil na agad or the foundation. Okay? So, yan lang muna. Maraming salamat sa panonood. And of course, see you sa next video natin.